An atom is the basic building block of matter, and is the smallest unit of an element that retains the chemical properties of that element. Atoms are made up of three types of particles: protons, neutrons, and electrons. Protons and neutrons are located in the nucleus of the atom, which is the central part of the atom. Electrons orbit the nucleus in shells or energy levels. Protons have a positive charge, while electrons have a negative charge. Neutrons have no charge and are neutral. The number of protons in the nucleus of an atom determines the element it is. For example, all atoms with 6 protons are carbon atoms. The number of neutrons can vary within an element, resulting in different isotopes. The size of an atom is incredibly small, with a diameter of around 0.1 to 0.5 nanometers. To put this into perspective, if an atom were the size of a football stadium, the nucleus would be the size of a grain of rice. Atoms play a fundamental role in our understanding of chemistry, physics, and materials science. By understanding the behavior of atoms, scientists have been able to develop technologies such as lasers, microchips, and medicines. The study of atoms has also led to groundbreaking discoveries in fields such as nuclear physics, quantum mechanics, and nanotechnology. Despite their small size, atoms are incredibly complex and fascinating entities. Their behavior is governed by the laws of physics and chemistry, and they interact with each other in countless ways to form the world around us. Understanding the properties of atoms and how they interact is crucial to understanding the nature of the universe itself. The concept of atoms has been around since ancient Greece, where the philosopher Democritus first proposed the idea of atomos, meaning indivisible in Greek, as the basic building block of matter. However, it wasn't until the 19th century that scientists began to develop a deeper understanding of the atom and its properties. In 1803, the English chemist John Dalton proposed a new theory of atoms based on his observations of chemical reactions. Dalton suggested that each element was composed of tiny, indivisible particles called atoms, and that these atoms could combine to form compounds. In the late 19th and early 20th centuries, experiments by scientists such as J.J. Thomson, Ernest Rutherford, and Niels Bohr helped to refine our understanding of the atom. Thomson discovered the electron, a negatively charged particle that orbits the nucleus of the atom. Rutherford's famous gold foil experiment showed that the atom has a small, positively charged nucleus at its center, with the electrons orbiting around it. Bohr proposed a new model of the atom that explained how electrons move between different energy levels, which helped to explain the behavior of atoms in chemical reactions. Today, our understanding of atoms is based on the principles of quantum mechanics, which describes the behavior of particles at the atomic and subatomic level. Scientists have developed a range of experimental techniques to study atoms, including spectroscopy, which uses light to probe the structure and behavior of atoms. One of the most important characteristics of atoms is their ability to combine with other atoms to form molecules. The chemical properties of an element are determined by the number and arrangement of its electrons, which determine how easily it can bond with other atoms. Different elements can form a wide range of molecules, which are the basis for all the substances we see around us. Another important characteristic of atoms is their stability. Atoms are stable when the number of protons and electrons is equal, which creates a neutral charge. Atoms can also gain or lose electrons to become ions, which can have a positive or negative charge. The stability of atoms is crucial to the stability of matter, and understanding the properties of atoms is essential to developing new materials and technologies. The structure of an atom is composed of three fundamental particles: protons, neutrons, and electrons. Protons and neutrons are located in the nucleus, which is located at the center of the atom, while electrons are found in orbitals or energy levels outside the nucleus. Protons have a positive electrical charge, while electrons have a negative electrical charge, and neutrons have no electrical charge. The number of protons in the nucleus of an atom determines the element it is, while the number of neutrons can vary within an element, resulting in different isotopes. The electrons in an atom are arranged in shells, or energy levels, which are organized according to their energy. Electrons closest to the nucleus are in lower energy levels, while electrons farther from the nucleus are in higher energy levels. The number of electrons in the outermost energy level, known as the valence shell, determines the chemical behavior of the atom, as it determines how easily the atom can bond with other atoms. The arrangement of electrons in an atom can be described using quantum numbers. The principal quantum number, n, describes the energy level of the electron, while the azimuthal quantum number, L, describes the shape of the orbital. The magnetic quantum number, m, describes the orientation of the orbital, and the spin quantum number, s, describes the spin of the electron. The nucleus of an atom contains protons and neutrons, which are held together by the strong nuclear force. This force is extremely powerful but operates only over very short distances, which is why the nucleus is relatively small compared to the overall size of the atom. The number of protons in the nucleus determines the atomic number of the element, while the total number of protons and neutrons determines the mass number. Overall, the structure of an atom is incredibly complex and fascinating, and understanding the behavior of atoms is crucial to understanding the properties of matter and developing new materials and technologies. Atoms have a variety of properties, some of which are intrinsic to the atom itself, while others depend on the interactions between atoms. Here are some of the most important properties of atoms. Atomic number. The atomic number of an atom is determined by the number of protons in the nucleus. It defines the element and determines its place in the periodic table. Mass number. The mass number of an atom is the sum of the number of protons and neutrons in the nucleus. Isotopes. Atoms of the same element can have different numbers of neutrons, resulting in isotopes with different mass numbers. Electron configuration. The arrangement of electrons in the energy levels around the nucleus determines the chemical behavior of the atom. Valency. The valency of an atom is determined by the number of electrons in its outermost energy level, which determines its ability to form chemical bonds with other atoms. Electronegativity. The electronegativity of an atom is a measure of its ability to attract electrons in a chemical bond. Ionization energy. The ionization energy of an atom is the amount of energy required to remove an electron from the atom. Atomic radius. The atomic radius of an atom is the distance between the nucleus and the outermost electron. Chemical reactivity. The chemical reactivity of an atom depends on its electron configuration and valency, which determine its ability to form chemical bonds with other atoms. Nuclear stability. The stability of the nucleus of an atom is determined by the balance between the strong nuclear force that holds the protons and neutrons together and the electromagnetic force that repels the positively charged protons. Unstable nuclei can undergo radioactive decay. These properties of atoms are crucial to our understanding of the behavior of matter and the development of new materials and technologies.